In this lesson, we'll take a look at how we can use participating volumes to add atmosphere to our renders. So let's go ahead and open up the start file that we're going to work with. Now, if you take this file and just quickly render this out, you can see that we have our trees, and this will be a little bit easier to see if you take a look at the alpha channel. We have our trees, and we have a light source that's directly behind these. Now, what we want to do is use the volumetric lighting effects in the participating volume to come in and start to add a little bit of atmosphere to this so we can start to get some light rays that actually pass through these trees. So in order to do this, we first need to create some kind of a geometry container for the volume itself. Now this can really be any piece of geometry, so we could use something like a NURBS, or rather a polygon cube. And we just need to scale this out and make sure that it encompasses our entire scene. So let's just take this and move it up. We also do want to make certain that the volume, or this geometry, also encompasses the light source that we want to use as the emission point for these rays. Alright, now you'll notice that this cube piece of geometry that we've just placed is now in front of the camera. So let's see what we can do to fix that. Let's go ahead and first just assign some sort of a new material to this. Really, it can be anything. So something like a Lambert material. And now all we need to do is take a look inside the shading group for this Lambert. Now there's a few options or a few materials that we need to hook up in order for this to work properly. The first is the actual volumetric material itself. So in our case, we're going to use the participating volume. And all we have to do is take this shading group, take a look inside the middle ray node, just middle click, and drop this into the volume shader slot. Now, whenever we try to render this, it will still render with the surface material of this Lambert. So we could either use something like a continue node, as far as the sample compositing goes, or we could use something like a transmat material, which will force this object to become transparent or render with no ray interaction. So we can take this transmat material, drop it onto the material shader slot, and there we go. So let's just take a quick render at what we have. Now rendering this, you'll see that we really don't have much of a change. So what we need to do is take a look inside the volume attributes and start to make some adjustments. Now the first attribute that we have is called the scatter. Now this is really referring to the color of this volumetric medium that we have. Right now, since it's set to black, we really see no effect of the volume whatsoever. So the first thing we need to do is take this scatter and begin increasing this. And now you can start to see the effect of the volume that we have. We now have a little bit more of a smoky type of atmosphere. Now you will notice, however, that the rays aren't behaving correctly. We don't actually have any kind of volumetric shadowing effects that we would expect to see as the light passes through these leaves and the branches. So in order for shadows to work correctly with some kind of a participating volume, you need to make certain that your light is connected to a mental ray light source. So in order to do this, let's just grab our point light, which right now is nested inside of this sphere, which is acting as our visible light source. And all we need to do is scroll down to the mental ray area, just expand this out, and hook up any kind of a mental ray light into the light shader. So let's connect this in, go over to the mental ray tab, and we can use something like a mental ray point light. There we go. And now we can begin to see the effect of the light rays as they pass through our geometry and start to now interact with the fog, or this volumetric material. So let's go back to the hypershade over here. Take a look back inside the volumetric material, or the participating volume. Below the scatter, we have an attribute that refers to the extinction. Now this is basically controlling how far our light is able to pass into the volume. Normally you would want to keep this set to a fairly low value, but if we start to increase this to something a little bit higher, now what we should start to see is an effect of light that's able to pass much less, or rather much shallower into this volumetric material. So let's take a render of this for comparison. And you can see now that's exactly what we get with this higher extinction rate. The light is actually dying off and not able to pass as far through this participating medium as compared to what we had before. Now, Below this, we have an attribute that refers to the non-uniformity. So right now, with this set to 0, we have a volumetric cloud that's very, very uniform. You can see that there is really no striations or any kind of differences in the density of the volume. You can especially see that right up in this corner. Really, right now, this is behaving as if we were in a vacuum. So if you wanted this to seem a little bit more realistic, we would want to start to increase this amount of non-uniformity. So that way we can start to get a little bit of variation in this effect. So let's, again, render this out. And now we start to get an effect that's a little bit smokier and has a little bit more of a cloudy appearance. If you compare what we had before, you can start to see now there is quite a bit more variation in the overall uniformity that we had. So we can just start to increase this a little bit more. And now it becomes much, much easier to see that variation, although you will start to notice that as we begin to increase this non-uniformity, our render times will also start to increase as well. So really just try to keep this to the minimum that you really need. Now below that, we have the controls for the minimum and the maximum step length. Now these are very, very important for controlling the rendered quality of our participating volume. For the moment, right now these are set to relatively high values. So the minimum and maximum step length, as we start to bring these down, let's say for the minimum step length, we'll bring this down to 0.01, and for the maximum, we'll bring this to about 0.1. So that way this minimum step length is about 1/10 of the value of this max. That's really a good rule of thumb to try to stay with. Now let's save a render for comparison. Now you can see how this goes a long way toward helping us eliminate a lot of these noise and speckled areas that we had before compared to what we have now. So this is a great way of starting to really start to boost the quality of our render, but you will start to notice that once you begin decreasing the minimum and maximum step lengths, that your render times will start to increase fairly significantly. So we've gone from about 35 seconds to start with now to a little over 3 minutes on my particular system to render this file. Now if we had multiple lights in our scene, we could use the light linking features in here to only link particular lights to this volumetric fog effect. So a couple of things that you do need to make certain of whenever using these volumetric effects. You need to make sure you have some kind of a containing geometry, that geometry is not renderable except for its participating volume, and then you also need to make sure that you have a mental ray light inside this volume so that we can take effect of these shadowing effects. So that's a look at the participating volume.